Hello, thank you for coming. I'm Marcel, and this is a new era of testing. So, who here is using JUnit 5 for their Android projects? Okay, that's more people than I expected. I love it. That's awesome. And for everybody else, let me try to persuade you in the next 40 minutes. So, JUnit 5 is the successor to JUnit 4. That's obvious. And JUnit 4 is the standard for testing on Android. The first public release of JUnit 5 was on September 11, 2016. That's almost to the day 8 years ago today. And JUnit 5 is rebuilt from scratch, and it's split into 3 parts, 3 components. I'll introduce these real quickly. We have Jupyter. This is the testing API for writing tests. In Jupyter, you have your test annotation. You have lifecycle annotations. And a lot of the cool features that I show you today in this talk are all from Jupyter. The second part is called the platform. And the platform is what runs your test. It executes them. This is implemented by Gradle, IntelliJ, Android Studio, so we as developers don't need to care about it that much. But please note, this is what executes your tests. The third piece is called Vintage. This is the backwards compatibility layer. With JUnit 5, you can also have old tests, JUnit 3 tests, JUnit 4 tests, and run them together with your new ones through the platform. And Vintage is the thing that makes that happen. This is the simplest test case that there is. If you create a new Android Studio project right now, you will get this class. And this uses JUnit 4, of course. So to start, let's change this to JUnit 5. Watch what happens. So only the imports have changed here, and the rest is exactly the same. And this is not an exciting example, of course, but I show it to you because I want to make clear that JUnit 5 still keeps the same foundation that you already know alive. It just makes it cooler with new stuff. You still have the same testing foundations, and we build on top of it with JUnit 5. So let's get into those cool features. My goal today is to show you the current state of testing with JUnit 5 for Android. And I want to talk about different kinds of tests, one after the other, starting with this first one. How about unit tests? It works. This is Android JUnit 5. You can find it if you scan this QR code. It takes you to GitHub. And this is a project that I started a few years ago. Android JUnit 5 is a set of developer tools for using JUnit 5 with Android. What you get is a Gradle plugin and some instrumentation test libraries that help you do your thing for those. We will get to those later. The first public release of Android JUnit 5 was September 11, 2017. That's exactly 1 year after JUnit 5 itself, and almost to the day 7 years ago. Let's talk about how you make your project use this. The first step that you want to do, we start with unit tests. You set up your dependencies. I'm using a version catalog file here, and what you do is, first, you apply the Android JUnit 5 plugin and its version like so. Then next, you want to add JUnit 5 and the Jupyter libraries. The latest version, as of today, is 5.11. And you add 3 library artifacts here. You see that there's 3 different lines. I will explain why there's 3 in a moment when we add them to the build. Also, if you have JUnit 4 right now, then you also have JUnit 4 in your catalog. And what you want to add is this last line here, the vintage engine. This is important too. And with that, we have set up our version catalog. Let's move over to the build script and actually put these to use. So the second step is you go into your module. I use the app module here. And I open the build script file. And first of all, I apply the plugin at the top. Like so. underneath your other plugins, you apply this one for Android JUnit 5. And then you scroll down and go to the dependencies, and you add the Jupyter dependencies. You see here there's 3 different ones. It's the same 3 ones from before. And first we have the API and the params. Those are implementation dependencies. I recommend to you that you always use API and params together. They split it into 2, but a lot of the cool features from today are from the params library, actually. So I always recommend you use both. The engine is a runtime-only dependency. That means you don't care about it when you write your tests, but at runtime, it's there. The engine is the glue between the JUnit 5 tests that you write and the platform that executes them. So it's basically the connector. And then, of course, if you have JUnit 4, you have the JUnit 4 dependency, and you add the vintage engine. The vintage engine is the glue between your old tests and the platform. You see how this works? It's the connector. And again, it's a runtime-only dependency. With that, we're good to go for unit tests. I'll show you a couple of examples now. So on the left, we have a JUnit 5 test class. On the right, we have a JUnit 4 test class. You see here, there's a sneak preview. One of the tests on the left is not a normal test. This is a repeated test. I will get to this later. Remember it for now. This is a kind of sneak preview of the kind of tests that you can do. But for now, let's just assume this runs, and you have a test report that has both test classes together. So the platform will run your JUnit 5 tests with the JUnit 4 tests together, like so. OK, that's all for unit tests for now. I want to focus on this next type for today. How about instrumentation tests? You know, the tests that run on your actual Android device. It works on API 26 and above. So this is the current distribution chart of API levels for Android. I downloaded this about 3 weeks ago, so it's pretty up to date. And you'll find that if you target SDK 26 or higher, you cover around 95% of active Android devices. So that's a pretty good coverage, but still, I need to explain why this min SDK requirement is there. So JUnit 5 is rebuilt from scratch, and it uses several Java 8 APIs. It's built on top of Java 8. So for example, it uses something called Simple File Visitor, also the NIO File API. And these are things that only exist from Java 8. And this means that you can only run the tests on an Android device that is also built on top of Java 8. And that is API 26 or higher. And we do have a process of desugaring, right? Where you can write new style Java code and it makes it work on old devices. But the problem is, desugaring does not give you Simple File Visitor and the other stuff. So desugaring doesn't help us here, unfortunately. So this means that when you run instrumentation tests with JUnit 5 on an old phone, you don't crash, and also you don't have to raise your min SDK to 26. That's also not the case, but your tests will be skipped on that old phone. So I will just skip over them. This is what that looks like. So here I ran this test suite on an Android 7 phone, and you see that the last class here is crossed out. It doesn't run. Also, in the logcat, you see a message like this, where it's just saying it's skipped, it's too old. So keep that in mind. Let's set up instrumentation tests, and then we're done with the setup, I promise. So for instrumentation tests, the first thing you want to do is you go to your module, build script, and you add the Jupyter dependencies to the Android test implementation this time. Again, API and params, they belong together. And then you have set this up. Step 2, there is no step 2. You're now ready to write instrumentation tests with JUnit 5. The plugin that you applied previously will give you the new APIs that you need automatically, based on what you use in your project. I will highlight these new APIs as we get to them. So with that all out of the way, let's finally write some JUnit 5 tests. Here is a basic test with activity scenario. Let's go through it one by one. This looks very similar to JUnit 4, but let's go through it. First, we have this extension here, the activity scenario extension. It's registered with this annotation, register extension. And this declaration is very similar to the test rule from JUnit 4, where you have the activity scenario rule. This time it's called extension. That's it, really. And then your test method really looks the same, right? This is Espresso API test, on view, with ID, click on stuff. You know this. So this is the same API. And one more time, you can write this exactly like it with JUnit 5. So it's not that exciting. So let's get into the cool features with JUnit 4 and make this more fancy. Watch. Here's another test with activity scenario and Espresso. But this one looks a bit different, doesn't it? Let's look into it more closely. You see here, this test method doesn't use add_test. It uses parameterized test. Also, there's another annotation on top called value source. There's two strings in it, login and register. And then finally, the method has a string parameter now, button label. Okay. If we execute this class like so, we get two test cases out of the single test method. The method is called once with the button label login, and then another time with register as the button label. So the same test method generated two cases for us. The reason why this works is because of value source. Value source is an example of what we call an argument source. These sources are what give inputs to your tests. And there are a lot more sources than just value source. I mean, look at this. There's so many of them. I'm not going to talk about all of them in detail, but I will talk about my favorite ones. Okay, value source. We've seen this already. This doesn't only work with strings, you can also use this with other stuff. Here's two examples. There's integers and classes. There's other Java primitives you can use too, so this is kind of flexible. And the methods have the corresponding type in the parameter body as well. If you run this, you get 6 cases out of 2 methods, 3 for integers and 3 for classes. Okay, next one. If you have an enum and you want to test something for all values of the enum, you can use enum source. If you make a declaration like this, you get 4 cases because there's 4 directions. So the same method generates 4 cases. Next, method source. You can have a static method that just generates and gives you the arguments. Because this is Kotlin, we have to go through the works and do companion object, JVM static. It's a bit of overhead that's required, but you see here that this is quite flexible. Also, pay attention to how this test method has 2 parameters. You're not just limited to 1. And that's because the arguments method returns arguments, and every argument has 2 things in it. So the method also has 2 things. If you run this, 3 cases out of 1 method. Next, field source. You can probably guess what this does. If you have a static field, you can make the field return your stuff. This was added very recently in 5.11, and yeah, it's pretty straightforward at this point. It's just a different way of doing this thing. 3 cases, 1 method, you get the D. Then, CSV source. This is the coolest thing you will see today. CSV source allows you to create comma-separated strings, put whatever you like, however you like, and it gives it to you as strongly typed parameters to your method. This example, we have a string name, an integer age, a char gender, and so on. And you see that the method signature here already, it's not all strings. You get it as a string, as an integer. It knows how to give it to you. There you go, 3 cases. Also, this Boolean at the end is the expected result. You can just declare a list of cases and the expected output, and then you test the same thing for all of these inputs. I use this all the time. All the time. again, there's more argument sources. Find me after, I can show you the other ones, but for now, that's it for argument sources. I want to move this into a more real-world example now, and I haven't shown Compose yet, so let's show some Compose instrumentation tests. Here's a bit of a more intricate example. We'll go through this together. So at the top, again, you have an extension, and you register it. And this is the JUnit 5 version of the Compose test rule. Again, it's not a test rule anymore. We have to use extensions in JUnit 5. And it's registered like this. Then there's CSV source, because it's amazing. And what this one does is it gives you a Boolean for dark theme, yes or no, and the font scale for normal font size and big font size, for example. And with this, a composable can be verified with light and dark theme, and also different font scales with the same method. There's no need to copy-paste. Then, parameterized test, you need that too. You see here, you can also give a custom format for the name that shows up in the test report if you don't like the default format. And then the method signature, 2 parameters again. And here, for Compose UI tests, you have to make use of this Compose extension. This is actually a difference to JUnit 4. You have to wrap your test inside this compose extension.use block. And then inside the block, you have your expected APIs. For example, you set the content. There's the theme. You give the parameters to the theme. And then inside, you have your composable. And the assertions after the set content, again, are the same API you know. You assert it on node with text, and so on. And from this test method, we generate four cases, because there was 4 things in the CSV source. And yeah, that is the result of that. So I want to move to a different feature of JUnit 5. I'm not going to talk about all the features. Again, find me after. I'll tell you all of it. But next, I want to talk about conditional test execution. It's a very fancy name for a very simple concept. Conditional test execution means that you can skip tests when certain conditions apply. That's it. For example, you can skip a test method if there is a certain environment variable set. You can execute a test only if you have a certain system property set. If you start Gradle with a certain parameter, only then run your test, for example. You can skip a test on a certain operating system. Always run this on Mac, never run this on Windows, and so on. If you have Android JUnit 5 in your project, I'll give you more things, more Android-specific things. You can skip tests or run them only on certain build manufacturers. If you have a bug that only exists on Samsung phones, and you probably do, then you can write a test specifically for that. You can also skip tests based on build config values, for example, or the API level of the device that's executing it. Let me show you a couple of examples for this. This test will only be executed if a certain environment variable is set. Let's read this annotation together. The test is enabled if the environment variable named CI matches true, this expression. So this will only run on your CI server. The second test will only run on your local because it is disabled when the same thing is true. When you have environment variable CI that is true, then it's disabled. You see that there's a difference in the name? All of these things have pairs. There's enabled and disabled. They work together like this. So let's look at some Android-specific ones for this. Here's that test only on Samsung test. So only if the build manufacturer is Samsung, then run this test. It's enabled. The second test is executed on all phones except for Google phones, because it's disabled if the build manufacturer is Google. Here's another one. This test will only run in debug builds. This, I find, is much easier than what I had to do before when you have an instrumentation test that only exists for a certain build type or even product flavor. We have a second version here. Instead of having a separate folder structure for instrumentation tests but only for production, or instrumentation tests but only for debug, you can have them all in the same one and then just control which one runs based on build config. So the second one will not run, it will be skipped in production, but staging it will run, for example. This is the last one. This test will only execute on phones from Android 8 to 11. It's only enabled on these SDK versions. And then conversely, the second method is disabled if your SDK is 33 or higher. So Android 13 or higher will skip. Older phones will run it. So hopefully you can get a feeling of how you can control the flow of your tests with these kind of annotations and tailor it to your needs. Let's move to a different kind of execution, parallel test execution. It is a tricky but very powerful topic. Parallel test execution means instead of running your tests one after one after one, you just run them at the same time. That's faster. It reduces the test execution time. And all unit tests can theoretically be parallelized. I say theoretically because you have to make sure that no two tests access the same resource, because then you get race conditions or flaky tests. We don't want that. Hence the word theoretically. For instrumentation tests, it's a bit of a different story, unfortunately. If you have UI instrumentation tests, you cannot parallelize them, unfortunately. And that's because of the way the Android instrumentation works. You know how when you run an instrumentation test, like the thing instruments the screen for you, like it scrolls, it clicks on stuff, you know? But the thing is, only one test has the attention of the screen at any time. So if two of them do it at the same time, it doesn't work. I tried, it crashes. So unfortunately, these kinds of UI tests cannot be parallelized. Compose, Espresso, yeah. But for non-UI tests, for example, if you have the Realm database, those tests have to run on an actual phone. Those you can parallelize because they don't touch UI. Okay, here is a slow test class. And here is what I showed you in the beginning. This is a repeated test. This just means this example runs 5 times. It's great for stress testing, so just run the method 5 times, that's it. And this method just puts itself to sleep for an amount of seconds. 1 second, then 2 seconds, and so on. Let's not question the practicality of this, I just want to make a point here. If we run this, then you see that the first execution takes 1 second, then 2 seconds, the third one takes 3 seconds, then comes the fourth one, it takes 4 seconds, and the fifth one takes 5 seconds. We just wasted 15 seconds of our life watching that animation. So we can make this faster, for sure. Parallel testing must be enabled in order for the platform to know that you want to use it. The way you do it is you open your build script. This is the last time we're going to do this, by the way. Open the app build script one more time. And if you have the Android JUnit 5 plugin applied, then you get access to this block, JUnit platform. And in there, you can configure it. And you configure it with configuration parameters. This is the JUnit 5 word for setting. There's a lot of these. You can look them up in the user guide. For parallel testing, this is the one that we want, and we want to set it to true. And if you do this, then you can opt in to parallel testing on a class-by-class basis. So returning to our slow test class, I made one change to the top. There's an execution annotation on top of it now. It has a value of concurrent. This tells the platform that when it gets to this class, you can run them in parallel. So if we do this again, all the 5 cases run at the same time. They're out of order, but it doesn't really matter. And it just runs them at the same time. And they're already done. I couldn't even finish the sentence. So that's a 3x improvement, because now it only takes 5 seconds instead of 15. Nice. So There's one more type of test that I have to talk about. I've mentioned that I've maintained Android JUnit 5 for 7 years now, and for all that time, people have asked me again and again about this kind of test. And my answer was always the same. No, sorry, doesn't work, we don't support it, dekinai. So the today's situation is a little bit different. So as this fades into view, and you may already know what I'm talking about, I have to ask one more final time, how about Robolectric? It works, but there's so much to do. There's so much work to do. Let's talk about Robolectric. So here's a brief overview of what Robolectric is. Robolectric is a framework for running unit tests with Android APIs. That means you do not need a physical device for this. You can just run them on your machine. Because of that, they are faster. You can also simulate hardware events to make your tests better, simulate the gyroscope and then do assertions. And there's other libraries built on top of Robolectric that are very cool, Roborazzi, Robospec, that we also want to use. Here's the test class with JUnit 4, and Robolectric is not applied. There's some Android APIs in this method. We see intent, URI, and so on. And if we run this without Robolectric, we crash. Most likely, you have seen this error before. Something is not mocked, whatever, run it on an actual phone. So that's annoying. And what Robolectric does is, you add it to your project, and you put this runner on top, and with just this change, the test passes. It's magic. So how does Robolectric do this? Again, this is a very high-level overview of how Robolectric works. Basically, Robolectric injects a version of the Android SDK into the runtime to let you call Android stuff. It does it through the class loader. It changes the class loader at runtime. That's the thing that loads in the class during your tests. And it replaces it with Robolectric's version instead of the thing that crashes. And the Robolectric test runner is the thing that does this handoff of class loaders. And that is, in a nutshell, how Robolectric works. Now here's a problem. JUnit 5 did not support class loaders, like custom class loaders, I should say, for a very, very long time. This is a very old GitHub issue from the JUnit 5 repository. They were asking for custom class loader support in March 2016. That's half a year before the first version of JUnit 5 had even come out, during the alpha experimental milestone stage. People were already asking for this. And implementation did not happen, support did not happen for years and years. Such a long time of waiting. We were getting confused. Maybe they forgot about it, I don't know. Then finally, in 2023, version 5.10 introduced custom class loaders. It's highlighted near the bottom there. So yeah, 7 years after, we finally had this ability. Nice. With this, Robolectric support was possible. But we had a new problem. Robolectric is a very complicated library, and nobody really wanted to attempt to make it work. Nobody was crazy enough to attempt to make it work. Everybody, this is Bolash. Bolash was crazy enough to attempt this and make it work. Earlier this year, he released the JUnit 5 Robolectric extension. Again, you can find it if you scan this QR code. I also link it from Android JUnit 5. It's an extension that basically does this class loader replacement for JUnit 5 to work with Robolectric. And it is still highly experimental, but it does work for the basic case. This is the first ever test class with JUnit 5 and Robolectric. We see that it uses the Jupyter API in the imports, so this is a proper JUnit 5 test, and the test method is the same. It uses intent, URI, and so on. What we add on top is this extension. We extend with the Robolectric extension. Now this is similar to the runner declaration from before, isn't it? So with this change, this class passes. Test works. It's magic. First time I saw this, my reaction was just like this guy. I could not believe it. So this is fantastic work by Bolash. However, I did say that it's highly experimental. And because of that, I have to talk about the future. Because there are some things that do not work right now, and I want to go through them so you can manage your expectations about this. So about the future, I can say we're working on it. What doesn't work? Exhibit 1. If you use Robolectric with Compose unit tests, there's an issue. So again, this is unit tests with Compose, not the ones on your phone. Those work fine, but unit tests with Compose and Robolectric together. If you do this together, then you crash. You get an error. This has to do with how the extension changes the class loader. It also has to change a bunch of the threading around the test environment. And the Compose testing API is really unhappy about this. So we need to fix this. What doesn't work? Exhibit 2. If you use Robolectric together with Espresso, you can cause a deadlock. This class has 2 methods with Espresso. Let's pretend the second one also has Espresso. And if you run this class with Robolectric and Espresso together, then the first one runs just fine. It's green. But the second one will run forever. Guru guru until the end of time. It will never stop. This also has to do with the changes to this threading model. Basically, Espresso has a internally hard-coded reference to the main thread, and the extension replaces the main thread. So the second test can no longer find the main thread, and Espresso just waits on this forever. What doesn't work? Exhibit 3. This is a result of the previous issues, really, but because their library is built on top of Robolectric, as of now, things like Roborazzi, Robospec are not really supported with JUnit 5. You can't really make good use of them. And I opened this pull request against Roborazzi earlier this year, where I implemented proper support for JUnit 5, but it's currently on hold because we have to fix these other things first. So in the future, I hope that I can provide a version of Roborazzi that uses JUnit 5 and to its fullest. Imagine using CSV source with Roborazzi for screenshots with parameters. Insane. Anyway, today is not that day just yet, so hold on tight. So to round off this talk, thank you again for coming. I would like to give my updated testing recommendation in the current year of our Lord 2024. In general, of course I'm biased, but in general I would recommend that you apply Android JUnit 5 to your projects in all cases, but where you apply it and actually use it for tests and not, maybe depends on a certain thing or two. So if you have unit tests that use Robolectric or Espresso, Compose, then you may want to stick to JUnit 4 for now. Use the vintage engine so that the platform will find your tests, but use JUnit 4. We have to give it a bit more time before it's mature enough. For literally any other test, view model, serialization, repository, domain logic, navigation, whatever it is, just use JUnit 5. You will love CSV source, you will love the other stuff. I haven't even talked about things like test composition and other stuff. Again, find me after, I'll gush about this all day. And for that, it is great. For instrumentation tests, the choice depends on your Min SDK, I would say. And if you have an older Min SDK and you are very open to experimentation, then maybe you can slowly start to write JUnit 5 tests. Again, it's the same as with Kotlin. We don't have to change everything at once. We can just slowly adopt it over time. But be aware that these things will not run on Android 7 and older. So just be mindful of that. If your Min SDK is 26 or higher even, then you can use JUnit 5 for all. There's literally no downside. Compose extension, activity scenario, you can just use it with the parameterized testing. With that, this has been a look at a new era of testing. I hope it lasts a long time. Thank you for listening. That's all.